How can something that feels so permanent be made of things that are almost entirely borrowed? You are looking at your hand right now, perhaps holding a phone or resting your palm on a wooden desk. You see skin, small creases, and the faint blue lines of veins underneath. It feels solid, but if you could zoom into the atoms making up your thumb, you would find a reality that is difficult to grasp. 90% of your body mass is composed of stardust, elements forged in the hearts of dying stars, while the hydrogen making up the remaining 10% of your atoms was created during the Big Bang. This means parts of you are 8 billion years old. You are a walking, breathing collection of the oldest things in existence. The story of your body didn't start with your parents or even on this planet. It began in a silent, freezing void where there was nothing but light and heat so intense it defies measurement. In 1948, a physicist named Ralph Alpher at Johns Hopkins worked with his mentor George Gamow to figure out where the first physical matter came from. They realized that in the first few minutes of time itself, the universe acted as a cosmic pressure cooker. It was so hot that protons and electrons smashed together to create the very first atoms. This was the birth of hydrogen. Every single glass of water you drink and every bit of moisture in your muscles contains that same hydrogen. It has been traveling through the dark for 8 billion years just to end up as part of you. Hydrogen is the basic building block, but it is simple to make the rest of you. The calcium in your teeth, the oxygen in your lungs, and the iron in your blood. The universe required a much more violent process. For billions of years, the cosmos was a lonely place filled with nothing but giant clouds of gas until the first stars ignited. These weren't like our sun. They were monsters inside their cores. The pressure was so great it began squeezing those simple hydrogen atoms together to make heavier elements. This is nuclear fusion. Scientists like Fred Hoyle at the University of Cambridge spent decades proving that stars are actually giant factories. They take the simple leftovers of the Big Bang and cook them into the complex materials needed for life. Think about the iron in your blood that carries oxygen to your brain. That iron was manufactured inside a star that was likely dozens of times larger than our sun. For millions of years, that star burned bright, fusing elements until it reached a breaking point. In 1957, a team of researchers including Margaret Burbidge and William Fowler published a massive study that changed our understanding of the heavens. They showed that when these giant stars run out of fuel, they don't just fade away. They collapse and explode with the power of an entire galaxy. This is a supernova. In that 1 second of total destruction, the star sprays its guts across the vacuum of space, seeding nearby gas clouds with the ingredients for planets, trees, and people. You are a recycled explosion. Every piece of gold in a wedding ring or the silver in a coin was likely created when two dead stars, known as neutron stars, crashed into each other. In 2010, physicist Brian Metzger predicted that these crashes create a specific flash of light called a kilonova. He was right. These collisions are so powerful they warp the fabric of space and time, throwing out clouds of heavy metals. Without these catastrophic, terrifying events happening in the deep past, your body would have no structure. You would be nothing but a cloud of invisible gas. The universe spent billions of years destroying stars just to gather the materials to build one human being. This cosmic supply chain is incredibly precise. If the heat of the early universe had been just a tiny bit different, the hydrogen in your body would never have formed. If stars didn't explode in exactly the right way, the oxygen you are breathing right now would be trapped forever inside a dead core at the center of the galaxy. We often think of space as something far away, something we look at through a telescope, but the truth is much more intimate. You are a graveyard of dead stars. The carbon in your DNA was once at the center of a red giant. The phosphorus that holds your cells together was forged in a blast that could be seen from the other side of the cosmos. To put this in perspective, consider the scale of time involved. The hydrogen in your left eye has existed since the dawn of time. It watched the first galaxies form and floated through the emptiness for 9 billion years before our solar system even existed. Then it was pulled in by gravity, trapped in a swirling disk of dust, and eventually became part of a planet called Earth. It waded through the age of dinosaurs and the rise of civilizations. Finally, it found its way into a molecule of water, which you drank, and now it helps you see the world. You are a collection of ancient travelers that have finally come together for a few decades to form a person. Scientists are still trying to map exactly how many stars had to die to make you. Some estimates suggest it took thousands of different stellar explosions, scattered across billions of light years, to provide the specific mix of elements in your body. Each one of those stars had its own life cycle and its own violent end. They acted like a massive, disorganized construction crew working across a vast distance. They didn't know they were building you, but every time one of them collapsed, the universe got one step closer to creating life. We are the way the universe finally gets to look back at itself and wonder where it all came from. This realization changes how you look at a simple night sky. Those points of light aren't just distant fireballs. They are the same kind of factories that built your bones and your brain. When you look at the stars, you are looking at your ancestors in the most literal sense possible. You share a chemical signature with the furthest reaches of the galaxy. The iron in your blood is the exact same iron found in the heart of a supernova millions of light years away. There is no separation between the up there of space and the down here of your daily life. The boundary is an illusion. Next time you feel small or insignificant, remember what it took to put you here. It took the birth of the universe and the death of countless stars. It took billions of years of cooling, collapsing and exploding. You are the final product of a 13.8 billion-year-old project. The most incredible part isn't just that you are made of stardust, but the specific way those atoms are arranged right now. How did the chaos of a dying star and the heat of the Big Bang coordinate to create something as complex as a human heart? The answer lies in the way gravity and chemistry spent eons turning those violent leftovers into a living world. Could the water you drank this morning be the oldest thing in the known universe? Physics suggests this is a fundamental truth rather than a line from a science fiction novel. About 10% of your body mass consists of hydrogen. This simple atom, built from just one proton and one orbiting electron, serves as the basic building block for everything else. But your body cannot manufacture hydrogen. Neither can the Earth, the Sun, or any star in the sky. Every single hydrogen atom currently residing in your cells was forged in the opening moments of time itself. In April 1948, physicist Ralph Alpher sat down with his mentor, George Gamow, at George Washington University. They wanted to solve a mystery that had baffled scientists for decades. Where did the universe get its ingredients? At the time, the prevailing theory was that the universe had always existed in a steady state, unchanging and eternal. Alpher and Gamow crunched the numbers and realized something different. They calculated that if the universe began as a hot, dense point, it would have acted like a cosmic pressure cooker. In a paper titled The Origin of Chemical Elements, they proposed that the first few minutes of existence were so violent that they manufactured the entire supply of hydrogen we see today. The conditions during those first 3 minutes were almost impossible to comprehend. The temperature exceeded 1 billion degrees. It was so hot that atoms could not even form. Instead, the universe was a chaotic soup of subatomic particles screaming through space. As the universe expanded, it began to cool down. During this brief window of cooling, protons and electrons finally slowed down enough to grab onto one another. They snapped together like magnetic building blocks. By the time the universe was 20 minutes old, the manufacturing process was over and the cosmic oven had turned off. To put that in perspective, every drop of water in your blood contains hydrogen that is 13.8 billion years old. These atoms have drifted through the void for eons. They have been pulled into swirling clouds of gas, trapped inside the gravity of growing planets, and eventually recycled into the food you eat and the water you drink. They are indestructible survivors of the greatest explosion in history. Scientists confirmed this in May 1965, when Arno Penzias and Robert Wilson at Bell Labs detected the faint afterglow of this event, known as the cosmic microwave background. It was the smoking gun that proved our atoms really do have a birth date. Hydrogen is just the beginning of the story. If you look at your hand, you see more than just hydrogen and water. You have calcium in your bones, iron in your blood, and carbon in your muscles. This is where the mystery deepens. While the Big Bang was effective at making light, simple atoms, it was actually terrible at making anything complex. The early universe was almost entirely hydrogen and helium. If the process had stopped there, the universe would be a boring, empty place. There would be no rocks, no trees, no oxygen to breathe, and no people to wonder about it. For a long time, scientists were stuck. They knew the Big Bang could not have made the heavy stuff. The answer came from a group of rebellious astronomers in the mid-1950s, including Fred Hoyle and E. Margaret Burbage in 1957. They published a landmark paper that changed how we view our place in the cosmos. They argued that if the Big Bang was the primary manufacturer of the universe's raw materials, then the stars were the high-tech factories that finished the job. They realized that the heavy elements that make life possible, such as the oxygen in your lungs, required a much more intense kind of pressure. Fred Hoyle, working at the University of Cambridge, focused on the specific problem of carbon. Carbon is the backbone of all life on Earth, but it is very difficult to make. It requires 3 helium atoms to smash together at exactly the same time in a process called the triple alpha process. The odds of this happening are incredibly low. Hoyle predicted that there must be a specific energy level within the carbon atom, a resonance that acts like a cosmic glue to make this collision easier. He was right in 1952. Edwin Salpeter and later William Fowler at Caltech confirmed that stars are perfectly tuned to create carbon. This means your body is a walking history book of 2 very different eras. You are a hybrid. Part of you was made in the sudden, white-hot flash of the beginning of time. The rest of you was slowly cooked inside the crushing nuclear furnace of a star. Every time you breathe, you are using oxygen that was squeezed into existence by the weight of a sun millions of miles away and millions of years ago. You are not just living on a planet. You are physically constructed from the debris of the objects you see in the night sky. But here is where it gets strange. Creating carbon and oxygen inside a star is one thing, but getting those elements out of the star and into your body is something else entirely. If the elements stayed trapped inside the stars, we would not be here. The stars have to die for us to live. They have to explode with enough force to scatter their guts across the galaxy. This realization led scientists to look at the most violent events in the universe. Supernovas, when a massive star runs out of fuel. It collapses and then rebounds in a blast so bright it can outshine an entire galaxy. Supernovas explain things like iron and nickel, but they still struggle to explain the really heavy stuff. Where did the gold in your wedding ring come from? Where did the iodine in your thyroid or the silver in your electronics originate? Scientists like Brian Metzger at Columbia University have recently found evidence that these elements require an even more extreme level of violence, specifically the collision of 2 dead stars. If the Big Bang gave you your hydrogen and stars gave you your carbon, then the rarest parts of you were forged in a crash so powerful it literally shook the fabric of space and time. Could you ever imagine that your own genetic code is built from the debris of a cosmic kitchen? If you peered inside your DNA, you would find a twisted ladder of atoms where every single rung consists of carbon. Yet carbon did not exist when the universe began. At the dawn of time, the cosmos was little more than a vast, hot fog of hydrogen to bridge the gap between a simple gas and the complexity of your biology. The environment of the universe had to change. In 1946, Fred Hoyle, a stubborn astronomer at the University of Cambridge, began to piece together a wild theory. He realized the universe required a furnace where simple atoms could be crushed into something new. When he looked at the night sky, he saw the answer staring back at him. Stars were not merely distant lights. They were giant pressure cookers. Gravity inside a star is so intense that it forces atoms to smash together in a process called nuclear fusion. Atoms naturally repel one another, but the crushing weight of a star forces them to become one. In 1952, Edwin Salpeter at Cornell University took this idea further by describing the triple alpha process. Imagine 3 helium atoms swirling in a furnace at 100 million degrees. If they collide with enough violence at exactly the right moment, they fuse and transform in that split second of cosmic heat. The star creates a brand new atom of carbon. This is the exact same carbon that now sits in your skin, your hair, and the cells of your brain. A star exists as a delicate balance, fighting against its own gravity for millions of years. As long as it has fuel to burn, the structure remains bright and stable. In 1957, a team of 4 scientists, Margaret Burbidge, Geoffrey Burbidge, William Fowler, and Fred Hoyle, published a massive paper that changed science forever. Today, astronomers refer to it as the B2FH paper. They proved that stars are factories rather than just burning balls of gas. Their work showed how stars build the oxygen you breathe and the nitrogen in the soil that grows your food. Every breath you take is a gift from a sun that lived and died long before our own solar system even existed. The oxygen in your lungs required a massive blue star to burn through its fuel at a frantic pace. These stars are huge, often 10 or 20 times the size of our sun. Because of their sheer mass, they run hot and die young. They spend their short lives fusing heavier elements in layers, much like the skin of an onion. Carbon turns to neon, which then turns to magnesium, followed by silicon. Each layer represents a different stage of the star's life. By the time William Fowler won the Nobel Prize in 1983 for his work on these reactions, the truth was clear: you are a walking, talking piece of the heavy machinery of the cosmos. However, a normal star eventually reaches a dead end at iron. You carry about 4 grams of iron in your body right now, mostly in your blood, where it acts like a tiny magnet to carry oxygen to your muscles. For a star, iron is a death sentence. Fusing iron sucks energy away instead of creating it. The moment a massive star starts producing iron in its core, the furnace shuts off and the outward pressure disappears. In less than a single second, the entire star, 1,000,000 times the mass of the Earth, collapses inward at 1/4 of the speed of light. This collapse triggers a supernova, the most violent event in the known universe. The star bounces off its own core and explodes with the brightness of an entire galaxy. In February 1987, humans watched this chaos unfold when a star exploded in a nearby satellite galaxy. Detectors deep underground in Japan and the United States felt ghost-like particles called neutrinos flooding past the Earth. This explosion is the only way the star can release its treasures. It shatters, screaming carbon, oxygen, and iron out into the cold vacuum of space. Without this destruction, the ingredients for life would remain trapped forever inside a dead star. While a supernova explains the iron in your blood, it cannot easily account for the gold in your wedding ring or the iodine in your thyroid. For decades, scientists like William Fowler struggled to figure out where the heaviest elements originated. They needed a collision so intense it would ripple the fabric of space and time. They started looking for neutron stars, which are the city-sized leftovers of dead suns. These objects are so dense that a single teaspoon of their material would weigh 1 billion tons. In 2010, Brian Metzger at Columbia University proposed that when 2 neutron stars collide, they create a kilonova. This flash of light is 1,000 times brighter than a standard supernova. In this chaos, neutrons are shoved into atoms at incredible speeds to create gold, platinum, and silver. In 2017, we finally saw it happen. Gravitational wave detectors felt a shimmer in space, and telescopes turned to see 2 neutron stars smashing together. We watch the universe manufacture a cloud of gold several times the mass of the Earth. The atoms in your jewelry and the rare metals in your smartphone were created in a crash between two dead stars. We used to think we were separate from the stars, just observers looking up from a rocky planet. The B2FH paper and the discovery of the kilonova proved the opposite. We are the survivors of cosmic shipwrecks. The iron in your blood and the carbon in your heart are the debris from ancient explosions. Every piece of you was bought with the life of a star. If 90% of you was forged in these violent stellar furnaces, what about the rest? A small, stubborn part of your body does not come from stars at all. It did not come from an explosion, and it was not cooked in a sun. About 10% of your atoms are much older than any star in the sky. To find the source of your most common atom, we have to look past the stars and go back to a time when the universe was less than 3 minutes old. What happened in those first few minutes to create the foundation of your entire body? Why does the metallic tang of blood from a paper cut feel so hauntingly familiar? That sharp taste is the direct aftermath of a cosmic catastrophe. The iron in your veins is a death warrant for a star. Deep inside the cores of massive suns, millions of light years away and billions of years ago, the universe was busy building the pieces of you. Fred Hoyle at the University of Cambridge spent the mid-20th century figuring out how these celestial furnaces work. He realized that stars spend most of their lives fusing light elements into heavier ones, operating much like a cosmic assembly line. But this process has a hard limit. As a star creates heavier and heavier elements, it eventually hits a wall of iron. Iron acts as the ultimate energy killer. When a star begins to produce this metal in its core, it no longer gains energy from the process but starts to lose it. In 1957, Margaret Burbage and her colleagues published a landmark paper that explained this grim reality. They showed that once a massive star develops an iron core, its fate is sealed in an instant. The outward pressure that holds the star up suddenly vanishes. Gravity, which has been waiting for millions of years, finally wins the tug of war. The star collapses inward at a fraction of the speed of light, slamming into itself with unimaginable force. This type Roman II supernova is a blast so powerful it can briefly outshine an entire galaxy of hundreds of billions of stars. If these stars didn't die in such a violent way, you wouldn't exist. All those elements built up inside the star, the oxygen you breathe and the iron in your blood, would stay trapped inside a cold, dead husk. The explosion serves as the delivery service. It scatters the star's guts across the vacuum of space, seeding the dark clouds of gas that will eventually become new planets and people. William Fowler, who later won a Nobel Prize for this work, proved that we are essentially walking around in the recycled remains of a massive explosion. You are built from the debris of a disaster. Every atom of iron in your body was once at the center of a star that was screaming toward its end. A supernova can create iron, but it isn't powerful enough to create the truly rare things you might be wearing right now. If you have a gold ring on your finger or a silver earring, a simple star death wasn't enough to make those. For decades, scientists like Fowler and Hoyle were puzzled. They knew the R process, a rapid way of building heavy atoms, existed, but they couldn't find a place in the universe hot and violent enough to trigger it. Supernovas were big, but they weren't big enough. The math simply did not account for the amount of gold we see in the universe today. There had to be an even darker, more energetic event lurking in the shadows of deep space. In 2010, Brian Metzger at Columbia University proposed a theory that sounded like science fiction. He suggested that the rarest elements in the universe, like gold, platinum, and uranium, are born when two neutron stars collide. Imagine two objects, each with the mass of our sun but crushed into the size of a small city, spinning around each other thousands of times per second. When they finally touch, they don't just explode. They rip the fabric of space-time itself. This event is called a kilonova. It is so rare that it only happens in our galaxy a few times every million years. Yet in that one blinding flash, The collision creates enough gold to equal the mass of several moons. Scientists still couldn't fully explain why gold was so scarce until they finally saw this happen in 2017. Telescopes around the world watched as two neutron stars merged, confirming Metzger's theory and detecting the literal signature of gold being forged in the wreckage. The jewelry you wear required a collision of two dead suns to exist. It is a level of violence that makes a standard supernova look like a flickering candle, while the iron in your blood came from a single dying star. The gold in your electronics and the wedding bands on your fingers came from a cosmic car crash between two of the densest objects in existence. These events are the only reason the universe has any complexity at all. If the universe had stayed as it was after the Big Bang, it would be a cold soup of hydrogen and helium. There would be no rocks, no water, and no life. We require the most violent deaths in the cosmos to provide the basic building blocks for a quiet afternoon in the park. The very atoms that allow your brain to process these words were forged in temperatures of billions of degrees and pressures that would crush a mountain into a grain of sand. A star 10 times the size of our sun lived for millions of years, burned through all its fuel, and blew itself into nothingness just so a tiny fraction of its dust could eventually end up in your hemoglobin. We are the beneficiaries of a billion-year-old graveyard. Every time you look at a rusty piece of metal or a gold coin, you are looking at the scars of the universe's most energetic moments. The materials that make up your physical body are not local. They are cosmic imports shipped across light years of empty space following the most powerful explosions known to physics. If we know where the iron and gold came from, we have to ask about the rest of the recipe. Most of the atoms in your body are incredibly common, but a small percentage of you is made of things so old they predate the stars themselves. We have tracked your blood back to the supernovas and your jewelry back to the colliding neutron stars. But what about the water that makes up the majority of your weight? To find the origin of the most vital part of you, we have to look back before the first star ever turned on. While 90% of you was forged in these violent stellar deaths, there is a remaining 10% of your body that is much older. It is a part of you that has remained unchanged since the dawn of time itself. To understand that, we have to go back to a moment when the entire universe was smaller than an atom. The question is, how did you survive the beginning of everything? Do you ever wonder if your own body is actually a map of the deep cosmos? Look at your hands and you see the faint blue lines of veins or the ridges of your fingerprints. A sight that feels entirely ordinary. Yet the atoms forming your skin and bone were forged in the most violent environments the universe has ever known. You are a walking collection of cosmic debris. Most of the oxygen you breathe and the carbon in your muscles originated in the slow, steady burning of stars like our sun. The most precious parts of you, those elements that make life complex and the world beautiful, required a much darker and more powerful event to exist. Consider the gold in a wedding ring or the silver in a piece of jewelry. These metals are rare on Earth and equally scarce throughout the entire cosmos. For decades, Fred Hoyle and Margaret Burbage understood how stars build common elements like oxygen or iron. But they reached a dead end when it came to the truly heavy stuff. A normal star, even a massive one, lacks the energy to crush atoms together into gold or platinum. The math failed to add up. For years, the origin of these elements remained a primary mystery in physics. Researchers knew something more extreme than a supernova had to be occurring in the dark. In 2010, Brian Metzger at Columbia University proposed a startling theory. He suggested that these heavy elements are born when two neutron stars collide. A neutron star is the collapsed core of a dead giant, a sphere so dense that a single teaspoon of its material weighs 1 billion tons. When two of these dead hearts spiral into each other, they rip the fabric of space itself. Brian Metzger predicted that this collision, called a kilonova, would spray out a cloud of heavy atoms like gold and uranium. It was a brilliant idea, but for 7 years it remained a set of equations on a chalkboard. Everything changed on August 17, 2017. The LIGO Observatory detected a tiny ripple in gravity, a literal shudder in the universe that had traveled for 130 million years to reach us. Simultaneously, telescopes spotted a flash of light in a distant galaxy. It was the first time humans ever witnessed two neutron stars smashing together at a fraction of the speed of light. The debris from that single crash contained enough gold to equal the mass of several Earths. This confirmed that the gold in your pocket and the iodine in your thyroid were created in a flash of heat so intense it defies human language. You can see the evidence of this ancient history in your daily life. The next time you hold a piece of gold, feel its weight, which is a direct result of the incredible density of the neutron stars that birthed it. You are holding a piece of a cosmic wreck. This isn't just about jewelry or expensive metals, as small amounts of these heavy elements are scattered throughout your body to help your cells function. You are not just made of the common dust of the sun. You are built from the wreckage of dead stars that refuse to go quietly into the night. Think about the scale of time involved in your own existence. The hydrogen in the water you drink has been around since the first 3 minutes of time itself. 13.8 billion years ago. The carbon in your DNA was cooked in the belly of a red giant star billions of years later. The rarest minerals in your blood were forged in a collision so powerful it shook the entire galaxy. You are a living bridge between the beginning of the universe and the present moment. Every time you touch your skin, you are touching the remnants of a billion-year-old explosion. What does this mean for how you see the world? It means that nothing about you is truly new. You are recycled light and ancient heat. When you look at the stars at night, you aren't looking at something separate from yourself, but rather at the factories that built your bones. Scientists now believe that almost every heavy element on the periodic table was delivered to Earth by these celestial events before our planet even formed. The Earth itself is a graveyard of stars, and we are the ghosts that rose from that dust. You can carry this perspective with you tomorrow morning. When you look in the mirror, remember that your eyes are made of atoms that once sat in the center of a star 3 times the size of the sun. The iron that makes your blood red was once the very thing that caused a giant star to collapse and explode. We often feel small in the face of the cosmos, but the truth is the exact opposite. The cosmos endured billions of years of transformation just to produce the specific ingredients required to make you. This realization changes the way we value our own lives and the world around us. We are not just observers of the universe. We are a way for the universe to look back at itself. Every breath you take is a connection to the Big Bang, and every heartbeat is powered by the energy of dead suns. We are the survivors of a long, violent, and beautiful journey through the deep reaches of space. You are not just on the Earth. You are a piece of the stars that has finally found a way to stand up and walk around. Take one last look at the palm of your hand and imagine the journey those atoms took to get there. They traveled across millions of light years and survived the death of worlds just to form you. The universe is not a cold, empty place. It is a grand construction project, and you are its masterpiece. You are 13.8 billion years in the making, and you are exactly where you were meant to be. Subscribe, a new breakdown like this every day.